Hi everyone, welcome back. And in this video, I'm going to go through the Chapter 1 lecture worksheet, which covers dimensional analysis and unit conversion with dimensional analysis. And also we'll learn about significant figures, and we'll also see density show up for the first time, and a few other small things that we'll sort of learn as we go. So what you want to do is print this worksheet out. You can find it in the Unit 1 folder. Go ahead and print it out. At the top of the worksheet here, I have a table of some common unit conversions, some that we will use in this video. You can also find on Canvas a few tables that I put in a folder called handouts to print. You can find in there a set of tables that you can use on exams. That sort of thing will help you do unit conversion. You'll also find a periodic table, which you're going to want to print out soon also. So what I'm going to do is go through each of these problems and show you how we can sort of read through the problem, figure out the dimensional analysis. So we'll look at analyzing it to find conversion factors and starting points. And then I will show you sort of the setup and then the answer. So if at any point you have any questions, please send me an email about this. So let's start with number one. Number one reads, your dad sends you to the hardware store to buy 1,000 nails for building a deck. It costs 95 cents per pound for the type of nail that you need. If there are 145 nails per pound, how much will it cost you to purchase the full quantity of nails required? Okay, so when we see a problem like this, there are a lot of other ways that you could solve this, some of which will get you to the correct answer, and some of which you might make a small mistake on. I'm going to be showing you the dimensional analysis setup not because you have to use that to solve this problem. Of course, you could use any method you'd like. What I'm showing you this dimensional analysis is for is so that when we go on to work on more chemistry-centric problems soon, you're going to find that it is very difficult for you because to adapt these other problem-solving methods to chemical problems because they're so sort of foreign to your normal understanding. These aren't dollars and cents and pounds and nails. It's molecules and grams and density and all of these different things. So I'm trying to teach you the method of dimensional analysis so that you can use it on any problem. So what we're going to do first is read through this, and I'm just going to try to point out some of the figures that we're given, and then we're going to try to figure out what those are, what they can be used for in dimensional analysis. So the first numerical thing we run into is we have the 1,000 nails. Okay, so I'm going to kind of write that over here. We have 1,000 nails, and that's what's needed. Okay, let's see what else we have. It costs, and it says here, dollars per pound. It's 95 cents per pound. So I'm going to sort of write that over here. We have 95 cents over 1 pound. And then we have, we kind of read through, that's the type of nail, and then we have 145 nails per pound. Now, if you watch the previous videos where I go over dimensional analysis, we see the word per. That's going to give us an indication that we have a ratio. So it's 145 nails per 1 pound. Okay? So these are the figures that we're given, and then we're being asked, how much will it cost? Okay, so I'm going to put a little like squiggly under this. So we're being asked about that, like how much in terms of dollars. So we're being requested to give dollars. So what we're going to do is look at each of these things and decide, is that a place where I would start my setup, or is that a conversion factor? And you might remember what I was saying in a previous lecture video was that whenever you have a ratio, that's a perfect opportunity to find a conversion factor. So both of these, I'm going to abbreviate conversion factor CF, would serve as excellent conversion factors because they are ratios. For instance, the first one lets us go from dollars to pounds, or from pounds to dollars. And the second one lets us go from nails to pounds, or from pounds to nails. So it lets us convert between either of those. Okay, so those are conversion factors that connect dollars to pounds, nails to pounds, and so on. Now, when we look at the other figure we have, which is just 1,000 nails, that's not a ratio, it's just a figure. So this is a good clue that this is our starting point. So I'm going to write start here. And really the method that we're going to use is we are going to go from nails, and we need to eventually get to dollars. But notice that our conversion factors here, if we look over at this one gives us nails in terms of pounds. So we can't convert directly into dollars, but we can convert into pounds. Now, we look at the second conversion factor, and we see that pounds lets us convert into dollars. So that will be our second step. So we're going to go from nails to pounds to dollars. That's going to be our setup for this. So let's erase some of these notes and then set up the problem using this scheme. So my starting point is going to be 1,000 nails. So I'm going to start by writing out 1,000 nails. And I need to convert the nails first into pounds. So I'm going to take a look at my conversion factors. I see this one here, which is pounds to nails. And since I'm converting into pounds, I'm going to have pounds as a unit on the top. So I have my 1 pound here, and I have 145 nails here. So that's my first step. That will convert nails into pounds by dividing by 145. But I'm not going to stop there. I'm going to keep going. The next step is now I'm in units of pounds. I need to convert pounds into dollars. So my next conversion factor will have dollars at the top, and it will have pounds at the bottom. So I take a look at this conversion factor, and I see the ratio is 95 cents per 1 pound. So that's my second step. So I've gone from nails to pounds to dollars. Now, if I just compute this, I take 1,000, I divide by 145, hit equals, and then I multiply by 0.95. And what you'll find is that you get $6.55. Now, this is money, and because it's money, significant figures is a little bit different. But let's apply the rules of sig figs that we already know. Let's take a look at what we have. First off, we need 1,000 nails. Now, that's a counting number, so that should be exact. So it has an infinite number of significant figures. For every 1 pound, there are 145 nails. Now, supposedly every box would contain 145 nails. However, it's likely that there's some kind of automated machine doing that, and errors are definitely possible. So I would say that this is roughly approximate, and it would be safe to say that it's 3 significant figures. Now, of course, that is a counting number, so this is up for debate. It's not necessarily absolutely true that this would have 3 significant figures, but I think it's a safe bet. Okay, and then we get over to our dollars per pound, and I would say here that it's probably safe to say that this is 2 significant figures. Even though we know that there are exactly 95 cents per 1 pound, you still have to measure the pound out. So let's just call it 2 significant figures, and we look at our terms. We're doing multiplication. We're limited by 2 significant figures. So if we wanted to round this, we would say it would be $6.60 with 2 significant figures. Notice here that I kept the 0 because it's money. And that's one of the problems with money is we show decimal place values because we can count money. So it's a little bit funny here because of that. But anyway, that's my analysis. So with that, let's go to the next problem. So problem number 2 here, let's read through it. If grapes sell for $2.15 per pound, and there are 255 grapes per pound, how many grapes can you buy for $8.15? Okay, so what we want to do is just walk through the sentence and pull out the conversion factors and try to find a place to start and possibly a destination. So the first thing we run into, the first figure, is here. We see this ratio of dollars to pounds. So I'm going to write that down over here in the margin. We have $2.15 per 1 pound of grapes. Okay. Now what that allows us to do is convert between dollars and pounds. So we can convert dollars into pounds with that, or we can convert pounds back into dollars. Okay, so it lets us go between dollars and pounds. Now, the next thing we run into is we have this 255 grapes per pound. Again, that word per, that tells us we have a ratio here. So we have 255 grapes per 1 pound of grapes. Now, what this lets us do is convert between the number of grapes and pounds. So I'm just going to write over here grapes, which we can convert into pounds, or we can convert pounds back into grapes. So that's what that does. Those are both conversion factors. Now, in the next part of the sentence, we see how many grapes can you buy? So we're being asked here to give an answer in the number of grapes. This is what's requested. Okay, so that'll be our answer. And then we have this $8.15 for $8.15. So we're going to walk into the store and try to convert our money into grapes. So this is where we're going to start from. We're going to start here. That's the starting point. It's not a conversion factor because that's what we're starting with, but it's a sign that it's not a conversion factor is there's no ratio. It's not $8.15 is just $8.15. It doesn't, that number itself doesn't explain what it can be used for. It could really be used for anything, right? So let's see how we're going to go about doing this. Well, we're starting with dollars. So let's write that down, $8.15. Now we want to get to the number of grapes, but notice that our conversion factors, I'll call this conversion factor 1 and conversion factor 2. Conversion factor 1 goes between dollars and pounds, not directly to grapes. And conversion factor 2 goes from pounds to grapes or grapes to pounds. So it doesn't involve money. So the first thing we need to do is we need to convert money into pounds. So that's what our first step will be. We'll have our first conversion will be from dollars. Right, we're going to cancel dollars out, and we're going to convert that into pounds. Okay, so we just need to have a conversion factor that expresses pounds and dollars, and you can find that over here with conversion factor 1. It turns out that 1 pound is converted with $2.15 by what we're given in the problem. So that's our first conversion factor. Okay, now the second one, we're going to convert pounds into something else. See, we've turned dollars into pounds. Dollars cancels here. And now the unit is pounds. So what can we turn pounds into? Well, if we look at conversion factor 2, we can turn it into grapes. From pounds. So it turns out there are 255 grapes per 1 pound. Now we can actually go ahead and solve this because pounds will cancel and we'll be left with grapes. So if we plug this in, 8.15 divided by 2.15 equals, and then multiply that by 255. And what you'll be left with is 967, I believe, grapes. And I'm not going to get into the sig figs on this one because, again, it's kind of, there are countables, there's money, it's just very awkward. It's not really worth us worrying about it. So if you have any questions about that one, let me know. Let's go to the next problem. Okay, so the next problem here is number 3. And let's kind of read through it. It says that gin used to be sold by the fifth, in quotes. And what that means is a fifth was actually 1/5 of a gallon. Now a bottle contains, instead of being fractions of a gallon, they're in liters or milliliters. And so a bottle now would be, of a similar size, would be 750 milliliters. So which one actually has more gin in it? Is it the fifth, which is 1/5 of a gallon, or is it the 750 milliliter size? Okay, so there are really two ways we can go about doing this. One way is we can convert milliliters. Sorry, my pen there. We can convert milliliters into gallons and compare. So we would start with, say, 750 milliliters and then convert it into gallons and then compare that with a fifth of a gallon. Or we could start with a fifth of a gallon. So I'll just write gallons here and convert that into milliliters and compare. So we could really do either way. Let's go ahead and do the milliliters way first. So I'm going to start with 750 milliliters. And notice there's a decimal point there. And I need to convert this into gallons. Now, if you're curious, well, how am I going to know that? Well, that's what the table of conversion factors is for. Milliliters is a metric unit, and gallons is an English unit. So I'm not expecting you to memorize that. Now let's take a look at this table and see if we can find anything that's helpful. Well, notice that we have up in this table, we have liters and gallons. So we can convert liters into gallons, but we have milliliters. Well, that shouldn't be a problem because we can convert milliliters into liters pretty easily because we know that there are 1,000 milliliters in a liter. That's part of our metric studies that we did already. So it's 3.785 liters per gallon. So let's get our conversion factors set up. The first thing we're going to do is convert milliliters into liters, because the next thing we're going to do is convert liters into gallons. That's because our conversion factor that we have lets us go between liters and gallons. So we have 750 milliliters to start. We're going to convert that into liters from milliliters, and then we're going to convert liters into gallons using our conversion factor. So we just need to fill in the numbers for all of these conversion factors. The units are set up correctly because milliliters and milliliters would cancel, liters and liters would cross cancel as well, and then we would be left with gallons. So let's put the numbers in. 1 gallon is shown as 3.785 liters, and that has 4 significant figures. And now we need our metric conversion. 1 liter is equal to 1,000 milliliters. And now we can actually do this computation. So we have 750 divided by 1,000, hit equals, and then we're going to divide by 3.785. And if we're expressing this to 3 significant figures, we should write this down as 0.198 gallons. Okay, so now that we have that number, we have to say, okay, well, how does that compare to a fifth of a gallon? Well, that's a pretty easy thing for us to do because we know that a fifth is a 1 over 5, and 1 over 5 is 0.2. So 1 over 5 equals 0.2. So 1/5 of a gallon is greater than 0.198 gallon. So we know that a fifth of a gallon was actually greater because it's larger than 750 milliliters when they're in the same unit system. Okay, so that's the basic idea. Let's go to the next problem, problem number 4, which lets us compare metric units for frequency. So let's just read through the problem first. It says convert 57,000 hertz to this capital M hertz. So let me write this down first. Hz, that's a Z there, sorry, is hertz. And you saw this first in, I think, the second lecture video where we talked about the different types of unit systems. And hertz is a part of the metric unit system and the SI system of units. And it's a frequency. And it happens to be per second. So how many times something is occurring per second? Okay, that's hertz. And M is a metric prefix. Okay. Now you're going to go ahead and learn the metric prefixes. What M stands for is 10 to the 6, or 1 million. It also means mega. So if you had a megabyte, for example, that would be a million bytes, or 10 to the 6 bytes. So we use that as a modifier to stand for the number 10 to the 6 power. Now what we're going to do is convert hertz into megahertz. So the best way to start doing that is to write down what we have and the conversion factors that will get to where we need to go. So let's write down what we're given. We have 57,000. And let's write the unit hertz there. Now, because we're converting from hertz into megahertz, what we need to do is write megahertz in our top position or numerator position for the conversion factor. And we're going to put a 1 there. And what we need on the bottom is we need the corresponding quantity, but not in units of megahertz. We need to know what 1 megahertz is in terms of hertz. So I'm going to write hertz down here. And what we're really doing is we're taking this M and we're replacing it on the bottom with the number that it represents. And we already know that M stands for 10 to the 6. So we're going to write 10 to the 6 power down below. Okay? Now it's a simple matter for us to do this conversion. We take 57,000, we divide it by 10 to the 6 power. Now if you're doing that on a calculator, make sure that when you do this, the 10 to the 6 power, that you've put that in parentheses, or you've used the exponential entry mode on your calculator to make sure that it puts the right priority and the numbers in the right place. Otherwise, you might not get the following answer, which is 0.057, and that's in terms of megahertz. Now, there's a few things that we should just double check. Significant figures. We have 2 significant figures in the beginning. This, our metric conversion, our metric conversion factor is exact. Why is that? Well, it turns out that's by definition. All of the metric conversions within the metric system are always exact. So that will never impact if you stay within the metric system, it will never decrease your number of significant figures because they're by definition. So that means our answer should have the same number of significant figures as our starting point, which is 2. So in this case, we are correct in writing this. So that is the first page. Let's go to the next page and look at a few more examples. Okay, so this next example, number 5, should probably be somewhat simpler now that you've done this a few times. So we're said a bullet train travels and it gives us the speed in kilometers per hour. And we're asked how many hours would it require to travel from Paris to Strasbourg, and the distance there is given in kilometers. So we're given kilometers. This is our starting point. So let's write it down, 491.7 kilometers. And we want to know how many hours it would take. So what that means is we need to convert kilometers into hours. So that's where we're going, and we need to make sure that our units of kilometers cancels. So we need to have a conversion factor that has hours per kilometer. That way that can happen. We're given one. It looks like this is our conversion factor. So we know that it's for every 1 hour, it travels 320 kilometers. So we just take 491.7, divide by 320, and we get 1.54. Notice that the unit that's left over is hours, so that would be our answer. Now, is this the right number of significant figures? Let's take a look. This has 4 significant figures. It's a measurement, so it has 4. It's not exact. And then also the rate of travel, the velocity for this train, is a measurement, and it has 2 significant figures. So that means our answer should only have 2 significant figures. So actually we need to round this, and it would become 1.5 hours. Okay, so if you got that right, great job. Okay, so if we look at number 6, we're going to see something new here. It says the volume of a container is listed as 515 cubic inches. What is the volume in liters? Now, what's new about this is the introduction of the cubic unit for inch. So we will, on occasion, deal with cubic units and squared units as well. So we should go through an example of that. So that's why this is here. Now, a cubic inch we would express with IN for the symbol for inches, and then cubic with the third power there representing cube. So what we're going to look at this is how to handle that little cube. And kind of the first step I'm going to go through is showing you kind of step-by-step kind of one way of thinking about this. The first thing that I want to do, though, is I want to show you the conversion factors that we have available. So on the first page, if you take a look at that table, you'll see that there is a conversion factor that expresses centimeters as a ratio to inches. And we see that it's 2.54 centimeters per 1 inch. And this is exact. And so that means it has an infinite number of significant figures. Okay, so that's one of our conversion factors. It lets us go between inches and centimeters. Another conversion factor that you'll see on the first page is the relationship between cubic centimeters and milliliters. These are both units of volume. So let's write those down. We see that there's a conversion factor that says that 1 milliliter can be expressed as 1 cubic centimeter, or vice versa. And then there's even another conversion factor, but this last one is actually one we know sort of in our heads. This is a metric system prefix, which metric system conversion, which expresses liters in terms of milliliters. And we know this because we know that m, the lowercase m, or milli, stands for 10 to the minus 3. So it's 10 to the minus 3 liters for every 1 milliliter. So it turns out with these three conversion factors, or variations of them, we can actually solve this problem. I'm going to put a 1 here, a 2 here, and a 3 here, just to number them if we're going to talk about them. Okay, so let's see what else we have. We're given 515 cubic inches. So let's write that down. 515 inches cubed. Now, if we sort of take a look at the conversion factors, we see that conversion factor 1 goes 2 centimeters from inches. So we can go from inches to centimeters. Well, let's take a look at how we might use that. So centimeters to inches. And then let's put the 2.54 here and the 1. Now this would be great. We could convert inches into centimeters this way, except that we don't have inches. We have inches cubed to begin with. So what that means is if we want to use cubic inches or cubic centimeters for that reason, for that matter, we need to simply cube our conversion factor. So all we need to do is if we want this to be 3 there, or a cube, what we need to do is put this in parentheses and put a cube there. This lets us convert between cubic inches and cubic centimeters now. Okay, so now that we've used that conversion factor, it's actually pretty easy to see how to get to the end of this. If we take a look at conversion factor 2, it goes from cubic centimeters into milliliters. So we would put that here. So if we had 1 cubic centimeter, that's equivalent to 1 milliliter. And then that uses that conversion factor. And then we go to the third conversion factor, and we see that it goes from milliliters into liters, which is what we're looking for. So we would go 1 milliliter down here is 10 to the negative 3 liters. And we can check our unit analysis, right, by cross-canceling units that match. So we have cubic inches here, canceling with cubic inches here. And then we have cubic centimeters, because we put that in parentheses and cubed it, canceling with cubic centimeters here. And then we have milliliters, canceling with milliliters, and then we are left with liters. So that's the unit analysis for this. And we're just going to plug this into the calculator by taking 515 and multiplying it by, make sure you use parentheses, 2.54 cubed, okay? Then you're going to, you can multiply and divide by 1, but basically what you're going to end up doing is multiplying by 10 to the negative third power. Again, making sure you use parentheses correctly. And the calculated value for this is, I believe, 8.439, and that would be units of liters. Now that's the calculated value. We need to make sure we have the right number of significant figures there. We see the first term, which is a measurement, is 3 significant figures. We have a metric, which is exact, a metric to English, which is defined as exact. We have a metric, which is exact. All the metric are always exact. And then we have another metric, which is exact. So our answer should be limited to 3 significant figures because that's the measurement. That's the only estimated value in here. Everything else is exact. So we will have these 3 as significant figures. So we would round this by going 8.4 and then 4. And that's in units of liters. So we've just converted cubic inches into liters. All right, so let's take a look at the next example. All right, so here in the next problem, we are being asked to convert the mass of this planet Neptune into from kilograms into tons. So we're going to need to do a metric conversion because kilograms is metric. We're going to need to go from the metric system into the imperial system or the English system. Things like pounds and tons. So if we look at the first page to see what conversion factors we have available, we have one that says that 1 ton is equal to 2,000 pounds exactly. So that must be a definition. And then we also have a conversion factor between pounds and grams. So we see that 1 pound is equal to 453.6 grams. And that's approximate, so that is 4 significant figures. So that means we need to be able to convert first into grams and then into tons from pounds. So we're basically going to start with our kilograms. We're going to convert those into grams. Then we're going to convert the grams into pounds. And then finally, we'll turn the pounds into tons. So it's 3 steps. Let's start here at the beginning. 1.024 times 10 to the 26 kilograms. Okay. Now the first step, we're converting into grams from kilograms. And then we're going to go from grams, we're turning into pounds. So that one's next from grams. And then we're turning pounds into tons from pounds. Okay, so that's our unit analysis. Notice that each place here up top, that's the unit I'm converting to next. And down here below, in the squares, that is the unit that I am just converting from. Okay, so it's like from and to. I'll write that down here. Okay, like that. This is the same always for every dimensional analysis. Okay, now we just, now that we have the unit analysis done, we just need to fill in sort of the numbers, the numerical representatives here. Okay, so the first one we'll look at is grams and kilograms. And now, K stands for 10 to the third. So if we had 1 kg, that would be the same as saying we had 10 to the 3g, like that. Okay, now we have grams and pounds. Okay, so we know that 1 pound is 453.6 grams because it's in the table. Now, just to remind you, you don't need to memorize that. These tables like that, the metric to English conversions, I'll give you those on an exam or a problem. Okay, now we're in the last conversion factor, which is tons and pounds, and we see that 1 ton is exactly 2,000 pounds. Okay, now let's write down our significant figures. This has 4 significant figures. This is exact, so it doesn't matter. This has 4 significant figures, and this is exact, so it doesn't matter. Now when we do our calculation, so this is down here, the result that we get is 1.12874 times 10 to the 23rd ton. Okay, so now we just need to round to 4 significant figures. So we see we have these digits here to be significant, and then we're going to be rounding that 8 because of the 7. So what we end up with is 1.129 times 10 to the 23rd tons. Okay, so that would be our answer. Great. Now let's go on to the next 2 problems. So let's look at number 8. Number 8 is a density problem. Now we haven't actually discussed density yet. So number 8 and the next one, I'm going to go to the next page here in a minute. I believe that's also a density problem. That's going to be actually a little better served for us after we've covered density, which is in the next chapter. So I think what we'll do is we're going to save this problem and the next one for review problems, so we can go over during the review. So I'm going to stop the video here. Please let me know if you have any questions about any of these. I hope that it's giving you some confidence working with dimensional analysis. There are additional problems like this, but varying in content and in difficulty on the problem sets that we have up on Canvas. So go ahead and try some of those, check your answers on the keys, and let me know if you have any questions. Hope you're doing well. Take care.